composition. This over here means composition.
Mhm.
And the notation is not super useful. I refer to this as a bubble. You read it as F composite G, but it's almost better said as F bubble G. This means to find G of 3 first, then find F of G of 3.
Mhm.
So we're first going to find G of 3. That means that X is 3, and you're looking in this data set on the right here. You're looking for 3 in the X position.
Mhm.
What is the Y value there?
-1.
-1. Okay. So -1 takes the place of this G of 3. So this is really taking the place of all that. This becomes now F of -1. So now you're looking for -1 in the other data set here for F. There's -1, and you're looking for the Y value,
Mhm.
which is 8. So you use the first function, and the idea is the output of the first function, which was -1, becomes the input to the next function.
Mhm.
Sounds like maybe you've not seen this before.
No.
Okay, yeah, kind of new.
Does
All right. Question?
I got none. Don't worry.
Okay. All right, number 2 here. Given F and G again, so same things. So this time you're going the other direction. Some students say goth. Goth and then fog, but it's really a bubble. It's not a letter, even though it kind of looks like an O. But what it means, just like before, is it's composition. It's have you heard of the nesting dolls or seen a nesting doll before, where there's like a doll inside another doll?
Oh, you mean those like matryoshkas from Russia?
Exactly.
Yeah.
Yeah. I thought they were the most. I had my aunt was in Germany for a while, and she brought me back one, and I thought it was the most coolest thing ever. But that's kind of what it is here. There's a function inside a function.
Mhm.
Okay. So the G bubble F of 3 means to start with F of 3. Start with F of 3, and then you take the result of that and use it for G. So you first figure out what is F of 3. So you're looking on the left here. Can you tell me what F of 3 is? Where do you see 3 as an X value in this list?
3 and comma -1.
So -1. And that becomes the input to the next one. So it's G of -1. That -1 replaces the F of 3. And now you're using the one on the right to get the next one. So -1, where do you see that over here on the right as the input, as the X?
-1 and 0.
Yes. So your answer is 0.
Hmm.
So it is one number when you're all done. It's just takes a little bit to get to that.
Got it.
All right. Now you can also do this with functions.
Got it.
So we're going to do that here for problem number 3. We're going to work on this as if it's functions. It's the same notation as the previous problem. Previous problems, you first find G of 1.
Mhm.
So F of G of 1 means to first find, looking on the right here, G of 1, and then next find F of G of 1. So notice you're given a function for G this time.
Mhm.
G of 1 means to put 1 in wherever you see an X. Now it's only the X that you're substituting in for. So think of the X as being in parentheses -1 squared plus 5. Okay. Could you go ahead and calculate this for us, please?
I gotta go put this into Desmos.
All right.
You got that? I just have to. It's a Desmos thing now.
You can use it for a lot of the problems we're going to do for the rest of the school year here.
Yeah. 4, positive 4.
Is positive 4. So that takes the place of g of 1. So now it's f of 4 that you're looking for. So the output of the inner one becomes the input of the outer one. F of x, we bring that down. F of x is 2x plus 3. You're putting 4 in for x. F of 4 equals 2 times 4 plus 3. So wherever you see an x, you replace it.
And now I'm going to use a calculator because they're fun. I got 11.
11, yeah. And that's your final answer.
Mm-hmm. All right, they're like kind of fun.
Yeah, as fun as math can be.
Yeah, because sometimes math does have fun things. That's a compliment because I really say that about math.
Yeah, it more you do, the more confidence you'll have, and you'll say, okay, I can do this. Now, unfortunately, it does ask if oh wait, the f and g functions are the same in example 4 and number 3 above. Is the answer the same? Can you look at example 4 and decide if it's f of g of 1 or maybe it's g of f of 1?
You want for number 4? You want me to look at? Okay, I'll look.
Yeah. Do you have a way to quickly look at example 4 for this?
Because while we're talking, I have the. Oh yeah, I see example 4.
Is it f of x 2x plus 3?
No. It's like example 4 shows is y squared plus 3x equal to 6 a function, and then it just asks us to solve for it.
Example 4 and number 3 above.
Maybe I'm looking at the wrong one. Hold on.
Yeah, maybe just double check. My guess is it's really similar to this. It's just g of f of 1.
Yeah, it's like given f and x equals 2x plus 3, and then so basically and gx it equals to negative x squared plus 5. So I can send you the photo if you want.
Yeah, probably want to do that. Or I can log in, I suppose.
I think you could log in. I think I showed you where to go look at other lessons, right?
Yeah, I was able to do that. It just takes me a little bit to get connected there. Do you want me to log in, or do you want us to just skip this problem and come back to it at a later time?
You can log in. It's okay.
Okay. All right. Let me get there. It's going to take me a moment. I don't have it quickly available, but we can get it here. All right, so you're whitmoreschool.org. All right, and then I think I had this. All right, got that. Copy. All right, I was able to log in. You said lesson 17, is that right?
Yes.
All right, so I found EX4. Yes, okay, so let me snip that in. This will make more sense now when I've snipped it in. All right, so what they're saying here is in example 4, it's 2x plus 3, and in g of x, it's minus x squared plus 5. These are the same as these two functions in your problem, but notice it's f bubble g of 1, and in this problem it's g bubble f of 1.
Mhm.
And the answer is not the same. You're comparing this minus 20 to your answer of 11. They are not the same. And the reason why we can say is because the functions, the original functions are not the same. Okay, so you can say that's the first thing you maybe say, is that the f of x is not equal to g of x. And the second thing you can say is that the order matters.
Mhm.
Which function you substituted in matters. I don't know if this is exactly what the instructor wants, but we can try that for this.
Well, I don't know either.
Let me know if you need more explanation than that.
No, I'm good.
Okay. The one other little thing here that I was mentioning earlier is that the pronunciation of fog and goff, that's referring back to f of g and g of f, fog and goff.
Mhm.
All right, let's move on to the next question here, which is
Number 5.
number 5 here. All right, so the given functions find the composition required, show workers. Okay, show the work. All right, here we go. All right, so we've got 15x minus 12 for f of x, and g of x is minus 15x squared plus 14x minus 10. Find f of g of -1. That means we're first going to find g of -1.
Mhm.
So we're going to use this function here, g of -1. Wherever you see an x, you put in -1.
Mhm.
Okay, so wherever you see an x, that's what function notation means. You substitute in. I'd always do it in parentheses. Could you calculate this for us, please?
Yeah, sure. Let me go pull up my Desmos. Negative 39.
I agree. Good. Okay, now the next thing is you take that result and you put it into f.
Okay.
So you're going to find f of minus 39. So we're using this function here, 15x minus 12. So wherever you see an x, you put in the value of x you just found.
All right. You have to go put that in Desmos, don't I?
Yes, unless you can do it by hand. You don't want to.
Oh, wow. Okay, that's a big number. 573.
573, you said?
Mhm.
Sounds right. Sorry, I was grabbing the next question. Just double check that, since I know you're getting a grade based on this.
So 573 is the answer?
I got 597.
Hmm.
15 times negative 39 minus 12. Do you want to try yours one more time?
Yeah. Let me see. Isn't it? Hold on. The 39 is negative, right?
Yes.
Yeah, I just changed that up. Yeah, I got now what you got, negative.
Good. Good. Excellent. All right. New problem here, number 6, whenever you're ready.
All right, I'm ready. Let's do
Okay.
this.
All right. So you look for the innermost thing. The innermost thing is g of -3. We're going to start with that. So g of -3, notice I write it underneath the g of x. You're putting -3 in for x. So again, you'll have to go to the calculator and determine that value.
All right. Positive 28.
Yes. Okay. Now, this is the first time I've seen this, but you can actually have the same function be used again.
Really?
So now you're still using G and you're going back to this one and putting that new value in to the function there. It's more common than you think to take the output in one thing and do it again in the same sort of scenario. It's like you repeat the process with the new result. So again, if you could calculate that for us, please.
Yeah, don't worry. Okay, I got negative 375.
Okay. Let me just double check that just in case. Nothing worse than getting, marked off and you got to go back and redo it. You said minus 375. That is correct. Good. That's the final answer.
Yeah, that's good. I didn't mess up my negative or positive.
Yep. Signs matter, right? It's like whether you're moving left or right, skating, forwards, backwards, it all matters.
Matters.
Yeah. All right, number 7. So 7, 8, and 9, this is the more difficult stuff. You're no longer dealing with numbers, just functions, just X, okay? So this one says G of X. That's what the GOG means here, G of X. So I'm going to write G of X twice. So you can see this minus X squared plus 5. G of X is minus X squared plus 5. So you take G of X right there and you put it in for X.
Mm-hmm.
And again, it's in parentheses. So it's minus parentheses minus X squared plus 5 squared plus 5. We're taking everything over here on the right and putting it in for X. Is that okay? Clear so far?
Yeah, I'm just trying to catch up.
Okay.
I'm ready. I'm caught up, by the way.
Okay, so the next thing here is whenever you see a binomial 2 terms squared, it's best to write it as the binomial times the binomial.
Mm-hmm.
And now we will use FOIL to simplify.
Oh, wow, really? Never would have guessed.
Yes.
I'm sorry, that was a sarcasm.
Lots to do here.
Mm-hmm.
All right, so the first times the first is minus X squared times minus X squared. That's positive X to the 4th. Minus X squared times positive 5 is minus 5X squared. 5 times minus X squared is minus 5X squared. 5 times 5
25.
is 25. You still have to bring this negative down, and you still have to bring this plus 5 down.
Got it.
Next thing is to bring the negative into everything inside the parentheses. But before that, I guess before that, we should combine like terms. So it's X to the 4th minus 10X squared plus 25. And then here we can distribute that negative to everything. Negative X to the 4th plus 10X squared minus 25 plus 5. Just the things inside parentheses have the sign change.
Mm-hmm.
And then lastly, you can combine like terms again.
Negative X to the 4th power plus 10X squared minus 20.
You got it.
That's
Then you take That's the answer.
Wow. I haven't seen a problem like this in a while.
Yeah, they might get the next ones might not be as long. It's hard to tell here. We'll see.
Mm,
All right. Let me know when you get all that down. We'll move on to number 8.
Yeah, I'm ready to go.
Fantastic. Okay, so this symbol here that's cut off, this is the square root of x for g of x. So you start with f of x, the innermost one. You always start with the innermost one there. And you're taking that function and you're putting it into the other one because the other one is g. It's the inside one goes into the outside one.
Mhm.
Yeah, the nesting dolls, right? The only way to stack them together is put the inside one, then bigger one, and then the bigger one.
Yeah.
So this one, like, believe it or not, is very, very short. We're done. You take x plus 3 and you put it in for x.
Mhm.
That's your answer. There's nothing more to do. You don't have to square. You don't have to do anything else.
Mhm. Right.
All right, number 9. All right, so for the g of x over here on the right, I want to just rewrite it slightly. It's 3 divided by x minus 1.
Mhm.
This time you're taking g of x, the inner one, the g of x, this g of x here, and you're putting that in to the other one.
Mhm.
So imagine it's in parentheses. It's 3 over x minus 1, and then this minus 1 is off to the side here. There's a little bit more to do here. I guess you guys haven't done this yet. Let me just look at your class to see when you guys are doing this. No, I guess maybe you did that last year in Algebra 1. Okay, so we're going to make a common denominator here on the right.
Mhm.
And your common denominator is x minus 1. So you're multiplying the top and bottom by x minus 1, just on the right there.
Mhm.
So this becomes x minus 1 over x minus 1. Do you see that since the bottoms are the same, we can combine the tops?
Yes.
Yeah, and the only little thing here is that the top's really in parentheses. So it's 3 minus parentheses x minus 1. It's not that you can only subtract the first one, they're both negated. 3 minus x plus 1 over x minus 1. This becomes 4 minus x over x minus 1.
All right. I'm caught up. I'm ready.
Okay, so that's the number 10. Doing great. All right, number 10.
I feel like this might be the fastest lesson we've ever had.
Yeah, it depends on the content. It really, depends on
Oh yeah, absolutely.
you go to a local mechanic to get your tires changed. The tires cost X dollars. There is a 6% sales tax, but you get a 10% discount. All right, write a function t of x for the total purchase amount after taxes, but before the discounts and fees. Okay, so the idea here is that since x is the price of the tires, cost of the tires, okay, but you have taxes, okay, and the tax is 6%, which is 0.06. But here's the thing, if you multiply 0.06 times x, that only gives you the tax. you have to add it to the original cost to get the total. And the total becomes 1.06x.
Mhm.
So if you just multiply by 0.6, that only gives you the tax amount. You have to add it back to the original. So you might as well multiply by 1.06 for that.
Mhm.
So that's everything for part A.
Mhm.
Part B. Write a function d of x for the total after discounts on purchase amount x, but before taxes and fees. Okay. So the idea here is that the discount is the 10% off.
Right.
Right. So if you multiply 0.1 times the price, that gives you the discount, but you end up having to subtract it from the original. So the discount is great, but what you care about, what I care about when I go make a purchase is how much of the original I'm actually going to pay, which is 0.9. So a 10% discount means you're paying 90% of the original price.
Mhm.
You've probably never thought of it that way, but we do this automatically. You go to the store, you have a coupon for 10%, and you know you're getting a certain amount off, but you actually really care about what you're paying. You don't actually care about the discounted price. You want to know what you actually have to put out for payment.
Mhm.
Is that okay?
Yeah, it's okay.
Clear. All right. These apply your knowledge, number 10s. I know these are a little bit maybe beyond what you would be comfortable with as a student because there's not a lot of numbers. Does it make a difference in the total price whether the mechanic adds the taxed first, d of t of x, or takes the discount first, t of d of x? Do not replace x with a numerical value. Show the work to support your answer while keeping x in your work. Okay. Normally we would. So whenever it tells you not to do something, when it says here, do not just use numbers, that actually is the best way to do these because it makes more sense to us when we're seeing the numbers. But we'll do it the way they've asked because they've asked it to do a certain way. So here's t of x, 1.06x, d of x is 0.9x. We're going to first calculate d of t of x. Okay, so this means to take t of x and put it in for x in the other equation. 0.9 times 1.06x. So go to your calculator and we're going to multiply 0.9 times 1.06.
So I'm just gonna catch up a little bit before I go straight to the
Sure,
calculator.
sure, yeah.
So you want me to multiply 0.9 times 1.06, right?
Yep, and then we're just going to put a little x next to it.
I got 0.954.
Like this, 0.954x.
Yes.
Okay. All right, now we're going to go the other direction. We're going to go the second one. It says t of d of x. And in the first problem, we took the t of x, the 1.06x, and we put it in over here on the right. Now we're going to go the other direction. We're going to take 0.9x and plug it in for the x over here.
Mhm.
You're going to do the same thing. You do 1.06 times 0.9. and see what that comes up with.
Same thing.
Yes. Okay, so that's the answer to this question. Does it make a difference? And the answer is no. No, it does not.
Right.
All right. Any questions on that before we move on to a new lesson?
I'm good.
All right. So since I've got this up, I'll just go to lesson 18 and get started there.
Yeah, it was speed running today.
All right. So I've got the first question up so we can look at that here. Let me know when you're ready for us to begin here.
Yeah. And I'm just taking the photos of our lesson so I can just upload them to Cam Scanner so I can submit them.
Good idea.
Yeah. Okay, I'm ready.
Okay, great. All right, so there's a very important thing that starts this lesson, which is for an inverse. The inverse, you have to do something pretty straightforward, and you don't need to know why, but you have to switch x and y.
Mhm.
So in this first ordered pair here, you're going to switch x and y. And then you do the same thing in the next ordered pair. And then you do the same thing in the next ordered pair. That's the most basic explanation of an inverse.
Mhm.
Switching x and y. Now, is it a function? So we've found the inverse, but is it a function? From the other day, I mentioned you're looking for duplicates in x.
Right.
Do you see any duplicates in x?
No.
No. So it is a function, yes. And the reason why or why not is for every input, there is a unique output.
Mhm. Okay.
Got it?
Yeah, got it.
Okay. All right, so for number 2, it's basically the same. I'd like you to switch the ordered pairs and give me the new ordered pairs when you switch or swap x and y.
First, okay, so we got, so it'd be 0, -5, right?
Good. Keep going.
0, -5. -1 and 3.
Good.
and then 0 and 5.
Good. So there's the inverse relation. You got that.
Yep.
Is it a function? First thing is to decide, are there any duplicates in X?
Yes, the zeros.
There's, so this potentially is a problem. Potentially, like we don't know for sure, but we know that this probably is not ideal. The question is, what does 0 go to? And notice it goes to 5, but it also goes to -5.
Yeah.
And this is bad. This is bad. This is like if you ask someone a question and you get an answer one time, and then you ask them the same question, you get a different answer. That's very unpredictable. So this is not a function. And the reason why is for input 0, there are 2 outputs. And that's confusing. It's like, well, which one is it? Don't know. Is that okay? Clear?
Yep.
All right, number 3 is to find the inverse of this function. Do you like to bake or cook? Do anything like that?
Not really, but like I really, I felt like a hobby.
So if you've ever wanted to make something, you might find a recipe.
Yeah.
And a lot of math is basically a recipe. There's step 1, step 2, step 3. So there's a recipe for finding the inverse. Okay, so step 1 is you write y equals 2x plus 3. Instead of the f of x, you put a y there. Step 2 is to switch x and y. So wherever you see a y, you put an x. Wherever you see an x, you put a y. Step 3 is to solve for y.
Someone not get confused.
So we're going to move some things around here. So your focus has to be on the side with the variable that you're solving for. So in this case, you're solving for y. What do you undo first? Multiplication by 2 or addition by 3?
Wait. Multiply by 2?
So when you're simplifying, you go this way.
Yeah.
But when you're solving, you're going back the other way, which means you undo addition and subtraction before multiplication and division.
You add by 3. Well, this time it would be subtraction.
Yes. And then I'm also going to do this. I'm just going to move sides. So I'm going to put the 2y on the left and x minus 3 on the right. You can always switch sides.
Mhm.
Okay. How do you undo this 2 in front of the y?
Divide.
Divide. And it's not a choice. You have to divide both by 2. So y equals x minus 3 over 2. And then the last step, step 4, is instead of y, you write f inverse of x for your final answer.
Okay, got that.
Now, the last thing it's asking you to decide here is the inverse relation a function? Is this a function? So
I would say it is.
well, it's not an opinion. It is, but you can't just say, well, I think it is, so it must be. But
I don't know.
so here I'm going to show you how to do that. We're going to graph it, but I'm going to do that for you here. So again, go into Desmos. One of the interesting things about Desmos that it takes a while for even for people like me to figure out that use this all the time. What I found, I don't necessarily like this. I cannot enter the graph as a function. I have to use y. I have to use y when I'm graphing. I can't just write f inverse of x. I have to graph it this way. And there's the graph of it. You can see that it goes on forever, right? It goes up forever, goes down forever, and things like that. Now, did we talk a little bit the other day about the vertical line test?
No. Oh, well, yes, you did.
So here's a vertical line. I'm going to draw my favorite vertical line. How many times does it hit the graph?
It hits the graph once.
How about this vertical line?
I would say once.
Once. So the question is there a vertical line that will hit it more than once?
No.
There is not. So this is a function. So yes, function. Okay. And the problem, or the wording is that it passes the vertical line test.
Okay.
All right. We're going to have enough time to, we don't really have enough time to finish 4. We can maybe start it. But we're going to run out of time here. I know we got a lesson tomorrow, so we'll probably have to pick up here.
Is it at 10 a.m.?
One other thing I guess I wanted to do here with you, because I think this would be important, is just sort of for schedule here. So you kind of got an idea here. If I put in the next couple of units, you know, we've done functions and we're working on inverses now. We're on 18. So like tomorrow we're going to finish that, but it says that this lesson will open up after the previous lessons have received a grade. So my question to you is like, is 19 going to open up tomorrow, or are you going to have to submit and wait for the
open? They're talking about lesson 20.
Oh, lesson 20. Got it. Okay. So our tentative plan is we're probably going to finish that. And then on Monday, we would get to lesson 20.
Yeah.
But the thing I guess to be on the lookout for is like, if these have to be graded, you know, if we just sort of say, okay, that's a Tuesday, Thursday, Friday, Monday, you know, Tuesday, Thursday, Friday thing. I guess that's okay.
Yeah.
What I don't want to have happen here is we get to a point where you can't get to the review, but
Yeah. I just don't submit lessons like every single day, because then my teacher's gonna be like, wow, this kid's speedy. I'd like give it a day. Like,
okay.
So my teacher's like, oh my God, okay.
All right. Yeah, I think we're on schedule. I'll definitely be talking to you about this, but we'll finish up lesson 18 tomorrow. We should get through 19. It'll be close. And then Monday we'll look at lesson 20. But that is going to do it for us for today. I'll go ahead and stop the recording right here. All right. Good job today.